Okay, guys, so today we are looking at lesson 4-3, which is on multiplying and dividing radicals. For your essential question, you need to explain how do you multiply and divide expressions that contain radicals. So here we have some rules of radicals as our vocab. And our first rule of radical is the multiplication rule of radical. So for this one, if you have the square root of A times the square root of B, as long as you have the same index. Now remember, the index is the root of the expression. And so when there's an invisible number there, it's a 2. So if we had, for example, the third root of A, we would not be able to multiply these together. So again, in order for you to multiply, you have to have the same index. So here we have the square root of A times the square root of B. And when you have that as the case, you can put them together under the same radical, and you can then simplify by multiplying your values together. So for example, if we had the square root of 3 times the square root of 2, we can take those values, because they both are square roots, even though the radicands are not the same, we can take those two numbers and put them together under the same radical and simplify, giving us the square root of 6. Now, after you multiply them together, if you find that you are then able to simplify that radical further using the cake method, then you would take it a step further and you would simplify that value as well. For division, it's very similar, only we're just looking at division. So if, for example, we have the square root of A divided by the square root of B, square root of B, we can then take those two values and put them together under the same radical and divide their values. And so if A is divisible by B, or if they can be reduced, then we would take it a step further and we reduce that. So let's take a look at an example. If we had the square root of 20 divided by the square root of 10, we could take those, put them under the same radical, 20 divided by 10, and then we could divide those values if they can simplify, and 20 divided by 10 gives us 2. Now, once again, if we find that that value can then be simplified using the cake method, we would then take it a step further and simplify that number by caking it. Right, so those are our rules of radicals with multiplication and division. Again, remember that the index must be the same. All right, so let's now take a look at some guided practice problems. All right, so first we're looking at multiplication. We have the square root of 21 times the square root of 6. Again, your index has to be the same. Now, that's not something that I'm going to be showing you guys this year where we change the index, but I just want you guys to know that that is the rule. So in the future, when you look at radicals with different index or roots, that you do not multiply them together unless they are the same. So because they are both square roots, we can take them and put them under the same radical. So we have 21 times 6, and that is going to give us the square root of 126. All right, so once we put them under the same radical, we want to then simplify. So we're going to take 126, and we are going to simplify it by using the cake method. So I divide out 2. 2 goes into 126, 63 times. We divide by 3 and 21, divided by 3 and 7, and divided by 7 and 1. So we have a pair of 3s, a leftover 2, and a leftover 7. We put that back together. Our leftovers go back inside the fridge, so that's 2 times 7. And one of our pairs goes out front. That then gives us 3 radical 14. Remember, from there, we can check our answer. In order to check our answer, we will take our outside number and square it. So 3 squared, that's 3 times 3 is 9. And 9 times 14 does give us 126. So we did simplify that correctly. All right, let's take a look at a couple of more. All right, here, now that we have coefficients, it's very similar. We still can only multiply numbers under the radical with other numbers under the radical. So what I'm going to do here is I'm going to kind of separate these. So we're going to have 4 times 3 on the outside because those are both outside numbers. And then on the inside, using the rules of radicals, we're going to have 10 times 6. So I like to say we multiply outside numbers with other outside numbers and inside numbers with other inside numbers. So we simplify this. 4 times 3 is going to give us 12. And 10 times 6 is going to give us 60. So from here, we're now going to simplify the square root of 60. So we're going to cake it. That will be 2 and 30, 2 and 15, 3 and 5, and 5 and 1. We have a pair of 2's, a leftover 3, and a leftover 5. That's going to give us 2. Square root 3 times 5 gives us 15. To check that, we square the 2. 2 times 2 is 4, and 4 times 15 does give us 60. So we did simplify the 60. We did good. Then we're going to bring the 12 and put that out in front of our final answer, and then simplify that. 12 times 2 is going to give us 24 radical 15. We have one more GP with multiplication. So here we have a square root of 6 times the quantity of 2 rad 3 plus 4 rad 8. So we have to use the distributive property here, and we will have to multiply that radical 6 to both terms. So we are going to distribute into the parentheses. Now, when we do that, again, we can only multiply inside numbers with other inside numbers. So we're going to have 2 square root 3 times 6 plus 4 square root 6 times 8. So this is going to give us 2 square root 18 plus 4 square root 48. Now remember, we can only add or subtract radicals that are like radicals. And here we have 18 and 48. Our radicans are not the same, but we can simplify. And maybe after we simplify, they could be the same and we could add them together, but we have to simplify before we make that decision. So we're going to simplify the square root of 18. That's going to give us 2 and 9, 3 and 3, and 3 and 1. So we have a pair of 3's and a leftover 2. And we also have to square root 48. So that's 2 and 24, 2 and 12, 2 and 6, 2 and 3, and 3 and 1. Pair of 2's, 2 pairs of 2's, and a leftover 3. So 2 pairs of 2's both go outside, and our leftovers go inside, giving us 4 radical 3. So let's check these really quickly. 3 squared is 9, and 9 times 2 is 18. That's what we had to start with. And here, 4 squared, 4 times 4 is 16, and 16 times 3 is 48. So those are both good to go. So now we're going to take them and rewrite this so that we can then use our coefficients as well. So for the square root of 18, that is 3 radical 2. So we're going to have 2 times 3 radical 2 plus 4 times 4 radical 3, giving us a final answer of 6 radical 2 plus 16 radical 3 So again, we do not have like radicals here, therefore we cannot add them together. And this is our final answer. Right, that is it for multiplying. Let's go ahead and take a look at division. So we have 2 times the square root of 10 divided by 3 times the square root of 2. So I'm going to go ahead and I'm going to separate this outside numbers with outside numbers and inside numbers with inside numbers. So because we have the square root of 10 and the square root of 2, we can put them under the same radical and simplify if possible. So 10 divided by 2 can be simplified because 10 divided by 2 gives us 5. So we have 2 over 3 times the square root of 5. Now, remember when I simplify this, there is an invisible 1 in the denominator, so we can multiply this back into one fraction. So I'm going to draw that just so you see it, but we typically obviously aren't going to see that 1 written in the denominator. So when you multiply your fractions, you multiply straight across, so top to top and bottom to bottom. So here we will have 2 radical 5 divided by 3 times 1, which is just 3. Now we would always simplify these outside numbers as well, if possible, but because 2 and 3 cannot be simplified, this is our final answer. Okay, let's take a look at one more division problem. So again, first thing I'm going to do with division is separate them. So we have 2 over 10, and then inside the radical, we will have 72 divided by 6. So 2 divided by 10 can be simplified to 1 over 5. Now this is not 5 over 1, this is 1 over 5. So be really careful when you're simplifying these fractions. Times 72 divided by 6 is going to give us 12. And again, that's over an invisible 1, just for the purposes of multiplying our fractions. We multiply straight across, top to top, bottom to bottom. 1 times the square root of 12 is just the square root of 12, divided by 5 times 1, which is 5. Now at this point, we need to try to simplify the radical. And on part A, we weren't able to simplify what we had in the radical, which was just a 5, but because we have 12, we're going to simplify that. So that's 2 and 6, 2 and 3, and 3 and 1. So the square root of 12 becomes 2 times the square root of 3. Our leftovers go back inside, over 5. Now again, at this point, if you could divide these outside numbers, when you cake and one of those pairs and the denominator share a common factor, you would divide that out. But 2 divided by 5 cannot be simplified. Therefore, this is our final answer. All right, there's one more GP. Here we have area of a rectangle. So back in lesson 4-2, we saw perimeter where we add up all the sides. Here we have area. Now remember, in order to find the area of a rectangle, we multiply the length times the width. Now it doesn't matter which one you call the length and which one you call the width because you're multiplying the order. Doesn't matter. So we are going to multiply the square root of 12 times 2 radical 2. Remember, you can multiply inside numbers with other inside numbers, so we can go ahead and rewrite this and multiply the 12 and the 2 together inside the radical, and that's going to give us a radicand of 24. From there, we want to check to see if we can simplify inside the radical. So that's 2 and 12, 2 and 6, 2 and 3, and 3 and 1. Oops. So we have a pair of 2s, a leftover 2 and a leftover 3. That's going to give us 2 radical 6 Bring that coefficient down from the previous step, multiply it to the outside number. 2 times 2 gives us 4, radical 6. And because this is area, we will say units squared. If it was inches, we would say inches squared. If it was feet, we would say feet squared. And that is it for 4-3.